In this class, we're going to consider how you add and subtract algebraic fractions. The good news is that the technique for adding or subtracting these guys is just like the equivalent for numerical fractions. So let's actually start by thinking about the numerical equivalent, and then we'll take that rule and we'll just adapt it to work through these examples. So the key is that if you've got two numerical fractions and you want to add or subtract them, then you need to make a common denominator. So this fraction is in thirds, this is in fifths. There are different types of fraction, different types of numbers, so you cannot add them directly. So what we do is we use a process to make a common denominator, and there's different ways to think of that, but usually it's just multiplying those guys together to make a common denominator of, well, in this case 15, and remembering to adjust also the numerators, which we do sort of by cross multiplying. So that's probably the easiest way to remember how to do that. So effectively what we're doing here is turning the two fractions into two different fractions, which we call equivalent fractions, because they're equivalent to the originals, but just written in a different way. So we're getting two new fractions, but they're equivalent to what we started off with. So 5 times 2 gives us 10 for the numerator for the first fraction. 5 times 3 gives us 15, which is going to be the common denominator. 3 times 4 gives us 12. And then 3 times 5 gives us 15 again. So now we've turned these guys into their equivalent fraction. Another way you can think about that is just that you've multiplied this one top and bottom by 3 to get 12 and 15, and we've multiplied this one top and bottom, numerator and denominator, by 5 to get 10 and 15. So now we've got these two new fractions. They're of the same type. We can go ahead and just add the numerator to get 22, and we keep that over 15. So it's kind of like a two-step process. You make the common denominators, and then you just add or subtract the numerator. So that's our answer for adding those two together. So we just want to take that technique and apply it to these algebraic fractions, and they've got different levels of kind of difficulty and different ways in which they're presented, but the overall technique never changes. It's making a common denominator, adding or subtracting. So this one is probably like a starting kind of question because we've got numerical denominators, which is a little easier than if they become algebraic. So we're just going to take the same approach. We're going to multiply these guys together to get the common denominator. In fact, it happens to be the same numbers we had over here, and then we're going to cross multiply to get the numerators. Just bear in mind that these are algebraic fractions, so you're going to have to create some algebraic terms as you do the multiplication. So 5 times x, instead of giving us just a number this time, it's going to give us 5x. Okay, the denominator will be 15, so 5 times 3, and then 3 times 2x, so multiplying up that way, gives us 6x, and then denominator is 15 again. So after that first step, we've got a common denominator, so we're good at this point just to combine them together. So just adding them together, so 5x plus 6x gives us 11x over 15. And that's us done basically with that one, so done at that point. Sometimes you'll find that this here might be an algebraic term and this would be a number term. And in that case, we cannot combine them. If we happen to have an x term here and an x term, we could combine those by adding them because they were like terms to make an 11x. If that was just a number though, we would just have to write it as, say that was just the number 6 instead of 6x, we would just have to write it as 5x plus 6 on the numerator because there's no way to combine a 5x and just a constant number like 6. So that might come up in some of the other examples, but I just thought I'd mention that at this point. So having a look at the second one, we can probably take away the red construction lines now. So just multiplying across the way and times in these together to get the denominators. So 4 times 5 is 20. 5 times x is 5x. So 5x is our common denominator this time. So this guy here and this guy here both had numerical denominators, numerical common denominator. This time we're going to have an algebraic denominator, but you'll see both. It doesn't matter. The technique is the same for both. So x times x gives us an x squared term. X times 5 gives us 5x again. So we've got the common denominator. Now we can just combine them. So this is what I was talking about a moment ago up here we've got a 20 and we're subtracting from that an x squared. We can't do that directly because they're not like terms. One's a number term, one's a x squared term, a variable term. So we're just going to write that as 20 minus x squared all over 5x. And that's all that we can do in that case, is just combine them by writing that we are combining them. And that's us done with that example. So that's the end point for that one. So that would be fairly typical of the kind of thing you might expect to get as an answer. They're not always going to be kind of neater like this. They might end up being a little bit messy, but what is the goal? What have we achieved? Well, here we had 2 fractions, now we've only got 1. And in certain algebraic scenarios, you might need for some reason to do that. Mainly because your math teacher is going to tell you that you've got to do it. So let's take a look at this one. Similar-ish to this one, but just slightly more terms on the top. We're just going to do the same thing again though. We're going to multiply these to make our common denominators and cross-multiply to get the numerators. When you cross-multiply, notice you're multiplying to this 2-term expression. So make sure you multiply to both. So one way you can control that is, so 5 times x plus 1 is by introducing a bracket. So you would go 5x plus 1 like that. The denominator is 5 times 2, which is 10, so that's going to be over 10. Going the other way, 2 times x plus 2, 2 bracket x plus 2. If your algebra is very good, if you're very confident already at doing that, then you don't need the bracket. You could go straight to making that 5x plus 5. So 5 times x is 5x, 5 times 1 is 5. If not, take that intermediate line. It's perfectly fine to do that. In fact, I would rather that you do that and get it correct, just for the sake of one line of working, than try and do too many things at once and sort of mess it up. So we're going to get 5x plus 5 over 10, plus the second fraction, 2x plus 4 over 10. Now we've got a common denominator and we can just combine all the terms together. So I'm just going to do all of this in one go. We're going to add the 2 fractions. All of this is going to become the top line. So 5x plus 5 plus 2x plus 4. But 5x plus 2x is just 7x, so we can go ahead and combine that. Or you could do an intermediate line of working where you just make that one big fraction over one of the tens. So 5x plus 2x is 7x, 5 plus 4 is 9, so the number term would be 9. So we end up with 7x plus 9 over 10. That's kind of more typical. These guys are important, but this is maybe your starting point. This is somewhere progressing forward a little. This is fairly typical of the type that you're maybe most likely to see. And that's kind of the point where you want to get quite comfortable with that sort of thing there. So the final example, I'm not going to work through. I'm just going to highlight it as maybe slightly more difficult than this one. So if you get to that point, that's great. You're doing really well. If you're ready to move on a little further, you might start to see things like this. And the things that make it different are the negative is more difficult to control when you've got a scenario where you've got, like, so we had a negative here, but we only had one term top and bottom. Here, we've got a term on the bottom with an expression with 2 terms, 2 parts to it. Kind of like we had up here, but here we had a plus. So having a negative in this scenario is more difficult. You've got to be more careful with the algebra. There's a little quirk to it. And also the fact that you've got algebraic, kind of binomial, I guess, 2 terms, not quite binomial, but 2 terms in the expression on the denominator. So this is a more complex scenario. The process is similar. We still need to make a common denominator, which we'll make by timesing these together, but there's just a few more quirks with this one. I'm just going to leave that. So this is enough to be getting on with to this point. Once you get to there, you'll be jumping up to this slightly higher level, which is maybe just an extra line of algebra possibly, but you've got to be more careful with that type. We cover these in the course, and this is kind of where we want to get to eventually with algebraic fractions. You'll see a lot of these in future math courses like Algebra 1, pre-calculus, and you would still be using this type of thing all the way through calculus. So these are an important type to be able to solve. So I hope that makes sense. Just remember that adding and subtracting algebraic fractions is just like the numerical equivalent. So if you're not comfortable with numerical fractions, adding and subtracting those, maybe get comfortable with those first. Make sure you're completely down with that and then move on to the algebraic fractions and work through these different levels of complexity. So if you're ready and comfortable with that, check out a few practice questions.